Welcome to clickmyproject.com. Let's discuss on the title Parkinson's disease tremor classification, a comparison between support vector machine and neural networks. Deep brain simulation has been used as a medical treatment for Parkinson's disease resting tremor, particularly for those with later stage of Parkinson's disease, since late 1980s. By placing an array of microelectrode inside a patient's basal ganglia, specific targets being the subthalamic nucleus called as SDN or the globus pallidus internus GPI, stimulating pulses can be applied to overcome some or all of the PD symptoms. It also means, however, that same electrode can be used to monitor and record electrical activity in this particular part of the brain, although it is not yet fully understood why DBS prevents tremor. It does not give the researchers a unique opportunity to understand a little how some of the signals in a specific part of the human brain change before and after the onset of Parkinson's disease tremor. So from the results described in this paper, they have not only used MLP, that is multi-layer perceptron neural network, and RBN in order to compare directly with the previously obtained results, but also for comparative purposes they have also considered the use of support vector machine as a signal pattern recognition device in this application area. SVM have in fact been widely used in similar types of classification tasks such as drug or non-drug classification and EEG classification. However, in this paper they have examined the performance of SVM for the classification of PD tremor using LFP signals collected from a real patient. We implement the project by making use of pattern recognition neural network and make a comparison with the existing phenomena. Now let's have the discussion on the data flow diagram. This is the data flow diagram designed to implement the project. We are collecting EMG signal data set for both normal and Parkinson's disease affected patient. You will be extracting the statistical feature extraction measures like skewness, kurtosis, mean, standard deviation as the feature extraction for EMG signal. It will be converted to feature vector representing each patient, and it will be fed to neural network, which is called as pattern recognition neural network. It follows feed-forward back propagation mechanism for learning. After training the network with the required features, you will be testing the network whether the learned parameters are correctly classified or not, and the patients will be classified as normal and abnormal. This is the training part. In testing part, you will be selecting any one of the signal, maybe in the data set or may not be in the data set. You will be extracting the same statistical feature extraction, namely kurtosis, skewness, mean, standard deviation, and you will be projecting it as a feature matrix. Then you will be providing it to the neural network testing part. A simulation will be done and your selected data will be represented either as a normal or Parkinson's disease affected person. Now we will have the execution of the program. Regarding the execution of the program, select main program.m and press run file. We will be getting a guide designed. This is your main program file. First I am loading the healthy patient EMG signal. The dataset is having some 10 patients. As the signal is displayed, the features will be extracted. The features are mean, moment, skewness, standard deviation, variance, and kurtosis. And this is an abnormal patient EMG signal, that is a Parkinson's disease affected person. And for that also the features will be computed. After that, we will be creating a feature vector creation by concatenating all the 20 patients. This is a guy representing the feature extraction. So when I click this, you will be getting at the start a feature vector arrangement. Column represents the patient and row represents the features. Then you will be classifying each patient whether he is a normal or Parkinson's disease affected person. So the classification table, this is a confusion matrix. 95% accurately your system predicts the person. Only one particular data is being misclassified. and 0 represents a normal patient, and the tag 1 represents Parkinson disease affected person. From the tag itself, only one normal patient is being misclassified under Parkinson category. The remaining category of images are being correctly classified. This is the training part and the testing part. Now you are going to select a patient as a query, and you are going to predict whether he is a normal patient or a Parkinson disease affected patient. So when you press a button select a patient, a dialog box applies. You can provide a signal from 1 to 20. I am giving signal number 15. This is the input signal of the 15th patient. You are going to extract the features. All the 6 features will be extracted, and these 6 features will be given to the neural network pattern recognition network to be classified. So your system has classified the patient as an abnormal. From the experimental analysis, we are clear that our system is able to produce 95% accuracy, which is better than any other classifier. It is compared with MLP, RBN and SVM, and this is the highest amount of percentage that is reached in classifying the input signal. Thank you.